Hey everybody, it's Mike, and what we're going to do in this video is we are going to go ahead and we are going to identify some exponential curves. I have a whole mess of them right here, and what I'm thinking is we can figure out which one's like a basic exponent, which ones are shifted, flipped, mirrored, translated, all of that. And my first criteria is going to be this right here. That's going to be my first criteria. This is the point 0, 1, right? 0, 1. And that means that we have some number being raised to the 0 and we get 1 out of it. So there's nothing translated, nothing rotated. Converse to that, this point over here, 0, negative 1, that would be negative some base being raised to 0 gives us a negative 1. And this is about the order of operations. So what I'm thinking right here is that this value right here, this is something like negative, I don't know, this is 1, so you're 1, 2, 3. So that's 3. So this is about negative 3 to the x. As x gets bigger, it gets more negative. So I think we've got negative 3 to the x because this looks to be about 1, 3. And that's the other thing we want to look at is this line right here. This value is right here. This is between 3. Let's switch to green. So this green one is between 3 and 2, so it's something between 2 and 3, and you know what's greater than 2 and less than 3 is e, so I'm going to guess that this green line right here, this green line is e to the x. It's not flipped backwards, it's not like twice as tall or anything, it's not negative e to the x, it's not e to the negative x, it's not shifted left, right, or anything. So I'm just going to go ahead and I'm going to guess that this is e to the x. Alright. Let's take a look at this blue line right here. Now, this blue line right here, this is going backwards. As x gets bigger, it gets smaller. So this is something, oops, doesn't want to draw here. So this is something to a negative x since it decays downward like that. This decaying exponential, that's a negative x. And let's take a look then at negative 1. Right here, this is 1, 2, 3, 4. So when x is negative 1, it's at a height of 4. So what number to the 1, right, to the negative 1 is equal to 4? That's going to be 4. So this line right here, this blue line right here is 4 to the negative x. Okay, so we took care of the blue one, we've taken care of the green one, we've taken care of the red one. We have purple and we have orange left to go. And what's interesting about both of them is when they pass through 0, they're not at height 1. So I think both of these are shifted. As a matter of fact, taking a look at this orange one right here, I'm going to highlight that spot right there. That's my point of interest. So at this orange one, when x is 1, that's when it's at a height 1. So that means you take your number, you raise it to the 1, you get 1 out of it. So this, we're like subtracting 1 from it, it's got to be. So we're taking our variable and we're subtracting 1 from it. Okay, and then let's go over here. Wait, this is really high now. This is suddenly at 0, 5. So this doesn't match. If I have some number, I raise it to the 0, and I subtract 1, that would be the number negative, which would be the reciprocal. So that's a big nope right there. That's not what we're looking at with that orange line. So that means this has to be negative. It has to be something like, this is at height 5, so we'll call it 5 to the negative x, and then we're shifting it, right? Well, let's put 1 in here. This would be 5 minus 1 minus 1. Nope, that's still not it. So let's cross these out. No. And this is a no. One more try. Let's see here. We need the negative x at 1, so we need minus 1 to cancel out, and that cancels out with a plus 1. So minus 1 plus 1. Okay. Minus, what in the world? There we go. Minus x, my color picker's acting up, plus 1. 5 to the minus x plus 1. We put a 0 in there. So at x equals 0, it's equal to 5 to the 1. Perfect, that's what we want. At x equals 1, we get 5 to the 0. Perfect, that's what we want. So this is, I'm just going to grab this color, 5 to the minus x plus 1, or 5 to the 1 minus x. Those are the same thing, just with a different order. And that leaves us with this purple graph right here. Once again, I'm interested in this point right here, 0, 0. Anything at 0 is really interesting. So this purple graph, I raise it, I stick a 0 in there, and there's something happening up in here. And what we get out of it is 0. That shouldn't be able to happen. Exponential functions, like looking at this green curve, it's never equal to 0. It can be equal to 1. So I think what's happening here is if you take something and you raise it to the 0, right, you get 1. So I'm taking my base, I'm raising it to the 0, and then I'm subtracting 1, and I'll get 1 minus 1, I'll get equal to 0. That's got to be what's going on. So I think then let's count out. We go out 1, right, to here, and then we go up to, so this should be 1. So this will be 1, 2, 3-ish. 3-ish. So I think that's 3 right here. 1, 3 looks like it. So then we have a number, we raise it to the 1, and we're subtracting 1, and we get equal to 3. So that means the number, let's make some space here. The number, right, a to the 1, that number minus 1 is equal to 3. That number better be equal to 4. Okay, so let's check this. We've got 4 to the x, then we subtract 1. At x equals 0, we get 4 to the 0 minus 1, which is 0. So that point checks out. At 1, we get, let's erase here, clear up a little bit of space. At 1, we're going to get 4 to the 1 minus 1, which is 3 minus 1, or 4 minus 1, which is 3. So that checks out. So we get 0, we get 3. I think that's got to be it. Fantastic. We've identified all of these equations. This is 4 to the x minus big minus 1, negative 3 to the x, 5 to the 1 minus x. The green one was e to the x, just a basic curve. This blue one was 4 minus x. So I think we've got a pretty good handle on how to identify these graphs when they transform.